capacity and channel coding. Information capacity and channel coding. Okay, this is our second unit. In first unit, we have studied about the information theory and source coding. In that, we have discussed about the compression techniques. How we can compress the data, how we can reduce the size of the data with respect to the bits, total bits content. At the time of encoding, we encode that symbols or signals by reducing the number of bits. Now, in that we have discussed about the source coding techniques. In source coding techniques, we have seen Lampert's coding, run length coding, Huffman coding, and the Shannon-Fano algorithm. Now, all these techniques are regarding the source coding techniques. Now, when we go towards the channel, at that time there is a channel coding techniques as well. So, in this unit, we have discussed about the channel coding. Channel coding. Okay, why we are going here for the channel? Because in any communication channel, we require source, then destination. Destination, it is nothing but a receiver and the channel. Okay, for this is the information source, it is a channel, and the destination. When we want to transfer some information from the source to the destination, at that time we require a medium through which we can send the data, and this medium, it is nothing but a channel. Now, when we want to transfer the maximum number of data from the source to the destination, from the transmitter to the receiver, at that time we require whatever the total information is there, that should be transferred in the minimum size. That's why we have discussed in first unit regarding the source coding. How we can reduce the data, same information we have to transmit, but whatever the size of that, we should be minimum. That's why there is a minimization of the data. Now, in first unit, we have discussed about the source. Now, the second thing, in the communication channel or in the transmission, and we require a channel. So, we have to focus towards the channel. That's why our second unit from this information theory and source coding, ITCCN subject, it is of information capacity and the channel coding. Now, already we have discussed about the information capacity. Now, we will go for this channel coding, which are the different techniques, different methods to channel coding. After that, we will in next unit we will discuss about the destination or the receiver. So, there is a need to see what is the role of channel in the transmission of the data. Now see, in source coding techniques, by using that we can improve the rate of information transmission. Okay, by using this we can improve the rate of transmission. Rate of transmission can be improved by using the source coding techniques. Source coding techniques. As we have improved the rate of transmission by using the source coding technique, now we have to go for the channel. As this information is transmitted over a channel, we need to take the effect of noise and bandwidth into consideration. When we are going for the channel, at that time we have to take the consideration of effect of the noise and the signal to noise ratio. Signal consideration of the channel capacity and the channel coding, as well as when we consider the noise and the SMR ratio, as well as we have to take the consideration of the reliability of the channel. So we have to discuss about the how we can increase the reliability of the communication channel. So reliability can be improved by the channel coding techniques. When we want to improve the reliability, we have to go for the channel coding techniques. Channel coding techniques. Now, the channel capacity. How we can define the channel capacity? Channel capacity, it is denoted by the C, capital C, and the unit for this channel capacity, it is bits per second. Bits per second. Now, how we can define channel capacity, or how we can calculate channel capacity of any channel in the transmission media or in the communication system? So, we have to derive the expression for the channel capacity. For that, we require a mutual information. Mutual information. In last unit, we have discussed about the mutual information, and mutual information can be expressed by I of x, y is equal to h of x minus h of x by y, and when there is an interrupt regarding the y, h of y minus h of y divided by x. This is the mutual information. By using these terms, we can find out the channel capacity CS is equal to when it will be a maximum of mutual information. At that time, we get a maximum channel capacity. Maximum channel capacity. Now, in this way, one by one, we can discuss about the different types of the channels. Okay, in the different types of the channel, we have to see the channel capacity of a binary symmetric channel. Remember this equation. Channel capacity, it is denoted by the capital C. Unit for this channel capacity, it is bits per second, and channel capacity can be defined by using the mutual information, and mutual information, it is denoted by the h of x, entropy of x minus h of x divided by y, and with respect to the y channel, it is minus h of y divided by x. Hence, when we get a maximum channel capacity, at that time only when there is a maximum of information content I of x and y. This is for the channel capacity. Now, next, channel capacity of a binary symmetric channel. Channel capacity of a binary symmetric channel. It is nothing but a binary symmetric channel. It is for the type of channel BSC, binary symmetric channel. For this, we have to see the diagram for this x0, x1. We are having the maximum pair probability for this P, probability for the P, 1 minus P, we have 1 minus P, and for this x0 and x1, we are having the output side, it is of y0 and y1. This is the figure for the binary symmetric channel BSC. See in this figure, why it is called as the symmetric channel. We are having the two information source the probability to reach the total information from the x0 towards the y0 as it is of 1 minus p. P nothing but a probability. When total information will be sent towards from the x0 to y1, it is of p, probability of p. And the maximum probability from the source x0 to the y0, it is of 1 minus p. Whatever the probability given, that should be minus by the total probability, 1 minus p. Okay, that's why in the symmetric channel, the probability of the information transfer, it is of the 1 by 2. That is nothing but a 50-50%. That's why it is called as the symmetric channel. By considering of probability of channel 0 and the 1. The probability of error be p, hence the probability of correct reaction is 1 minus p. Now see the equation for this binary symmetric channel. As these are equiprobable, hence p of x0 is equal to p of x1 is equal to 1 by 2. That's why it is called as the symmetric channel having the probabilities of equiprobable relation. Equiprobable relation. That's why there is a 1 by 2. As it is comes from the half information to the y0, remaining half it is to the y1. That's why it is called as the equiprobable. And information x0 and x1 are 0 and 1 respectively. That's why CS channel capacity, it is of the maximum when we consider as I of x comma y, when p of x0 is equal to p of x1 is equal to 1 by 2. That's why it is called as the equiprobable relation of the mutual information. That's why we can find out the total capacity for this binary symmetric channel by using the derivation of this. We see the derivation for this. Hence the channel capacity CS equal to 1 minus HP. 1 minus HP. Why it is of 1 minus HP? Because from this equation, previous equation, we get the total probability of the error, whatever the total information, 1 minus the total entropy of the H minus P. That's why in the channel coding, we require this channel coding and the information capacity to improve the reliability of that channel.